Hello, 1, 1, 1, 1. Yes, great. So I hope everybody had a chance to grab some food for lunch and also grab a coffee. I'm very excited to be here to talk about the challenges regarding urban air mobility from a test and measurement point of view. So my name is Tobias Willuhn. I'm working for the company Rodhe and Schwartz. And I would like to start with an apology because I missed the party yesterday because of some reason I will talk about in a couple of seconds. But before I start, I would like to know you a little bit more better and understand the audience. So raise your hand if you ever heard of such a thing like a spectrum analyzer. Oh, great, awesome. So I think I have some interesting stuff for you coming up. So the topic I want to talk to you about is urban air mobility. We heard a lot of things about costs, about how to address the market, about what will be key in order to become a leader in this market. And I would like to share a couple of ideas and thoughts about what technologies might be important for this and how test and measurement can be part of that. But before we go there, this is my reason for not being here yesterday. So you might have heard it in the news. Our CEO was yesterday in Ingolstadt signing the memorandum of intent for a project called Urban Air Mobility Ingolstadt, which basically is a test bed for beyond visual line of sight technologies and urban air mobility. Currently, 40 companies are part of this network and of this project. And by the way, Airbus launched their City Airbus aircraft yesterday. Rodhe und Schwartz is a German company based in Munich, southern Germany. We are looking into fields like test and measurement and broadcast media. Aerospace, defense, and security is a big topic. For example, we have a very nice solution for our friends at Gatwick in RF monitoring that can detect and analyze a drone signal that is coming, that might be close to the parameter of the airport. And the latest part of the business is cybersecurity, because we understand there's a growing need for that. So what is the vision of urban air mobility? What's it all about? Don't take my word, but listen to Dennis Muhlenberg, who said, I think this is, it will happen very fast, and maybe faster than we understand. Real prototype vehicles are being built right now, so the technology is very doable. And I think it's kind of funny that Airbus and Volocopter already showed that these vehicles are being built, and we will see more in the future. Last year, I was able to attend the Uber Elevate Summit in Los Angeles, and the remarks from John Langford really stuck, from my point of view, stuck out of the mentionings, because he said taking the human out of the cockpit and really creating a full autonomous vehicle is absolutely key to UAM economies. Why is that? Because I think he clearly understands that having a pilot in a 6-seater or a 10-seater or even a 4-seater will bring up costs to a point where it's not attractive to be in the business anymore. I would also like to quote Dr. Frank Anton, who was actually scheduled to be here and give a speech about his developments at Siemens. He was also at Ingolstadt yesterday, attending the launch of the City Airbus, because Siemens is actually providing the electrical drives for the City Airbus. And he said last year, the biggest bottleneck will be the development of an economy of scale to offer affordable services. So scale is definitely something that all the manufacturers of UAM vehicles need to look into in order to make this fly for the right price. So let's talk about the market. Let's talk about technologies, barriers, and market condition. Since we brought it up earlier in the discussion, this is definitely a chart that has been designed by NASA engineers, just showing off what they understand and how complicated you can make it. I don't know if you understand what they're trying to say, but for me, this is basically what we are looking into. So we try to analyze from a test and measurement point of view what are the key technologies for urban air mobility that will finally drive the industry and that will make the vision of urban air mobility happen. And we have to think of technologies like, for example, autonomy, sensing, communication, cybersecurity, propulsion. All these topics are key to make these vehicles fly. All of these technologies, well, maybe there's a slight difference. So from our understanding, there are a couple of really key technologies that need to be enabled in order to drive this industry. And these are autonomy, sensing, communication, cybersecurity, operations. All of them are key in order to bring forward an industry that is affordable and perceived as safe. And I think this is really important. Not everybody is really keen in jumping into an eVTOL. There might be people out there being really afraid of it. And if you saw the latest viral video about a Airbus A320 doing these shaking wings somewhere in Europe, if that happens to a Volocopter or some other smaller vehicle, I think this is really a key issue. So these urban vehicles, these eVTOLs, need to be really nimble, and they need to be very well designed. So what is the current status? Is this all new technology? Do we need to drive this from scratch? No. I think if you look at current developments in the aircraft industry, there's definitely something and some industries that you can already see developing and coming forward. And I think it's very interesting to understand how the industry will work with these existing technologies and how the industry will look at new technologies that may be coming from a different industry perspective. For example, automotive. It is not by chance that in Ingolstadt, Airbus and Audi joined together in order to work on concepts for urban air mobility, because I think what the automotive industry can bring is the scale factor. They are working on electric drives, they are working on batteries, they are working on technology that is on a mass scale, while Airbus, for example, brings in the understanding of what is needed in order to provide safe and secure flying conditions and flying services. And also here, you see a couple of topics, a couple of technologies regarding navigation, regarding car entertainment, and regarding communication that are already in place and already applicable. And the question is now, what will we see in a future vehicle for urban air mobility? So let me quote again Dr. Anton on a remark that he made just a couple of weeks ago or months ago in Cologne at the Electric and Hybrid conference, where he talked about the challenges that it brings when you put a very strong electric motor or electric drive in a very small vehicle. If you have a chassis out of carbon fiber, if you have the need for reliable communication, if you have the need for reliable sensors and precise navigation. And he said EMI and EMC will be one of the most challenging parts of that. Why? Because I think he fully understands that if you have these electric drives that he's building for example for the Airbus helicopter, then these drives are built up in a way that they have a very high power to weight ratio. How do you do that? You take off all the shielding. So they are really light. And that will later on show in the spectrum. So what is a spectrum? Here is finally something for all these spectrum analyzer lovers. I brought for you an example from one of our flagships, the FSW, where we're looking at the ISM band on a 300 megahertz real-time bandwidth. And what you are about to see is not the actual spectrum, so it's not the actual flow. Excuse me. It is rather statistics on what peaks you've seen over a certain time length. And I'm going to show the video to you. And it's interesting to see what the different color schemes do. So for example, the blue lines are the ones you want to look for. Why? Because those are sporadic, those are not on a regular base. Everything that's red, that is pretty obviously seen, but those who are blue, those you don't see. So in a real-time environment, you would probably see much more spectrum happening than on this chart. And it just gives a picture of what you look for in terms of EMI and EMC challenges. So let's look at a design for a general urban air mobility vehicle. So you want to have sensors for the autonomous flight. You want to have communication. You want to have a downlink. You have strong electric drives. You have electric power. And all of that has an impact on your spectrum that you have around the vehicle. So for example, you will see all the 4 electric drives definitely in the spectrum. You will fly in an urban environment. So what do we have in an urban environment? We have lots of things going on in the spectrum. LTE, 5G, all the DAB, all these emissions you have in an urban environment, they also add to the complexity in terms of emitter spectrums and analysis. So what do we test for? What is the standard that we're looking at in order to address these challenges? Well, the question is, there are a couple of standards out there, but will they really address the need that manufacturers for urban air mobility vehicles have? And in order to give you a little bit insight on this, we are looking on a graph, costs versus time. And basically, there are 2 different standards. There's one side on the military side, which is very high, very sophisticated, because they have been exposed to high emissions on a very early stage. And there's the general civil standard that is applicable for all the commercial aircrafts. Question is now, where do you test? Where do you put your test strategy exactly on spot? If you go higher than the military standard, you're creating a very safe airplane or eVTOL, but you probably are not competitive because you have very high costs. If you go below the commercial standard, you probably might taking the risk of not getting certification for being able to transport people. So the really interesting area is the one that is between the military and the civil standard area. And if you look at it on a time domain and on a cost domain, I think there are some lessons learned in terms of your strategy. So clearly, when you look at the costs, the differentiation between a military and the civil standard gives you your margin. If you go all the way up, you have no margin left. If you go all the way down, you have a margin, but you trade that in for safety. On the time axis, putting efforts and costs into being there at an early stage will probably make you a market leader. While on the other side, taking more time for tests will probably bring you in a position of a fast follow. Currently, with the UAM market in a phase where we see a lot of interest to be there in the first place, I think a lot of people want to be there in a market leader position. So let's take a closer look at this area, market leader. There is an optimum in terms of testing. And this optimum provides you with a clear advantage regarding taking a market share in the UAM business or losing a market share. So the red area is where you have higher costs, where you probably lose the market share because of your cost structure, while the green area is probably providing you with a benefit in terms of taking market share because you have a very interesting price point. And this is the direct lesson learned from a smart test strategy. It directly hits your market potential. So the question is, where's the optimum? This one I leave for an offline discussion. This one we cannot disclose. So in a nutshell, I think what is interesting to understand, and maybe also for the investors, but also for the UAM manufacturers, the key success factor in the UAM market is to provide a seamless integrated system design that provides a unique, safe, and affordable user experience. I think the user experience is really key. You will not get people in these aircrafts if they don't feel safe and if the user experience is not on the same level as they are experiencing in a car or even in public transport or in a normal aircraft. And a smart EMI and EMC test strategy is a key building block for successful design and will prove to be a major differentiator in the future market. With the example I just showed you, you will clearly see that one of the major cost drivers is test and measurement, and EMI, EMC has a direct impact on the overall integration of the design of these vehicles. So definitely something to look for. All right. Thank you very much. With that, I'm happy to take your questions.